And so if you look at if you're paying it, like we were working our way through these notes, right? And we just finished the graphical user interfaces, which I think we got it complete enough, right? I think right at the end there, I think we did it. I think I went through everything that I wanted to. Your next homework that I saw, that I'm going to assign Friday, is taking your gunner and putting it in here, okay? And so it shouldn't be that hard, but it will be, right? Because you got to extract the parts and put it in there and stuff, but you can play with that. So then what I did last time, this was kind of the last little push. And what I did last time is I introduced these things called anonymous functions, and then I talked about ordinary differential equation solvers that are based off of those things, and it gets really weird. And then I looked at the homework, and I was like, oh my God, I made them do this last time? There's no way that they were able to do this. And then this is the one where ChatGPT couldn't do it. But I want to make sure I leave enough time for MathCAD. So as of right now, I'm going to skip over this section, right? Because it gets really weird, and you can see part of this is MATLAB can't solve. This is for differential equations. It can't solve second order differential equations or third order or fourth order differential equations, but it can solve systems of first order differential equations. And you have to do this weird stuff to it where you introduce these new variables, and it gets nuts, and I don't want to do that right now. So the last things that I really want to cover in for the MATLAB side of stuff is the symbolic toolbox, right? Because this I use all the time. This is super helpful. So we're going to do symbolic toolbox, and I gave you some new notes for that. I haven't decided. It's homework 8 or 7 was the really complex one.
Oh, so we still have one this Friday.
Yeah. That's the putting in the graphical user interface.
Oh, yeah.
The one this Friday. And then there'll be one more after that where we're going to use the symbolic toolbox. And then the other thing I want to cover is data filtering. This is something that I use quite a bit as well. Like if you have a bunch of random noisy readings that you read in through like accelerometers or loads or something, there's ways of like cleaning it and filtering it so that you're pulling out relevant information out of it. And I'd like to cover that aspect of it, right? So kind of going through and fitting. This black line is a fitted curve to this. Like you have all the noise, and we can put in this fitted thing, and it pulls out the most important part of it. We'll do that, and then that's it. Okay, that's it for the MATLAB stuff. Unless I decide to do the ODE stuff, ordinary differential equation and anonymous functions. Now.
That's what we're getting tested on?
Yes. So that brings up test. Thank you for bringing up test, Sean. Thanks for bringing up test. Thoughts on that is potentially before spring break. Because then we're like 2 weeks. Huh? Well, and then after class, then we're gonna do MathCAD, and then we're gonna show Python, and then we're gonna show some of these other things. But like while it's fresh in our mind and we're like deep into MATLAB, let's do it. We'll do it like the 12th.
What are the other thoughts? Like it doesn't happen.
It doesn't happen, or we just don't do it.
We do the Wednesday portion, right?
The 12th. The 12th.
Wow.
Is that the Wednesday?
I'll make it work.
And so then what I'll do, because that will give room for one more homework this Friday to next Friday. Right? And so what I'll do is I'll just make this homework twice as long. I'll just add some of this stuff in here instead just to cram it in, just to get it done. And that'll be right now there's gonna be the graphical user interface, then I'll add in a symbolic portion to it, and then a data filtering portion to it, and that'll be due next Friday, and then that's it. Then after that, once you've done all that, you've done all your MATLAB, and then we'll do the exam.
Okay.
Yeah. And then and we'll even do a review day. That Monday will be a review day, right? And in fact, I found this the other day, and I'm really proud of Mike Berry from 2 years ago. I made a Kahoot. I did. I was really proud of this. A Kahoot that is structured very similar to how the test will be, like similar types of questions. Here's a structure of code. Here's a section of code. What's the output? Here's a section of code. What's the output? Yeah, I'm pretty proud of myself from 2 years ago. Okay. So put that down. March 12th, 3/12. I'm doing my Structures 1 exam that day too.
with that too.
Sounds good.
Because you don't want to do it.
No, in Robin's class, I have to do the 3-minute thesis right before his class.
You can tell him no, and he'll change it.
Me?
Yeah.
No, I
No,
stick
I also
to it.
I do want to get over before spring break.
Yeah.
Do it on Monday. We can do that. We can do the
We could
Monday.
push the exam back to
No, I'd like to
the
do.
last half of Wednesday and have like a half take home portion. And do the Super Bowl.
Yeah.
That's not a bad idea. The take-home portion, except for
No, that's
how can you enter this into ChatGPT, right? Like,
Or all take home.
all take home and just.
Yeah, spring break test.
I like
Yeah.
Right. Yep.
No, I think it's a good idea.
Okay.
I'm just having my own existential crisis back here.
All right. Let's do this. Right. So let's talk about this. So this is notes. This is available on D2L. Right. And I put this together. Like I said, me and Chat put this together, and it was letting me down. And I don't like the structure, but it was rush at the end. But this is good enough. Okay. I know.
Wait, chat meetings.
Yeah. Kind of. I mean, it did a lot of the stuff for me. Like it makes these environments and stuff like that, and it's in LaTeX code is what it is, and it knows how to program in LaTeX code and stuff. But anyways, so symbolic, right? Everything we've done so far, and I've said this before, MATLAB and what it's originally created for, and its real strength is numeric computation, right? That right when you're trying to plot x and y. X has to be a vector of numbers. Y has to be a vector of numbers. You don't give it the function. You don't say, here's a function, plot this function. You kind of do because your Y values are calculated based on a function given X's, right? But it's everything has a numeric value, right? But then that's great, and that's what it's made for, and it's really efficient at it. But then in the last 10 years or so, they're like, sometimes you want to solve stuff analytically, right? An example would be in your homework problem with the projectile. I gave you the equation. You had to solve for Tmax. If you really want to solve for Tmax and come up with an equation for Tmax, MATLAB can't help you with that normally unless you use the symbolic toolbox. So you could set up the equation and solve for what T is, and then it'll give you, it'll solve for T, and it'll give you the equation of T. And so symbolically, it has some tools, and there's a toolbox called Symbolic Toolbox. So when you installed MATLAB on your computers, hopefully you installed the Symbolic Toolbox. If you did not, and you tried to use some of the Symbolic Toolbox, I think MATLAB will say, hey, you should have installed the Symbolic Toolbox, and then it'll give you a button, you click on it, and I think it'll go take you and install it. Anybody do this? Did you do this?
Yeah.
When?
Yeah.
Oh, today, right now, you just tried it?
No, for like one of the homeworks. I don't remember what I was doing.
Okay, you accidentally ended up on Symbolic Toolbox. So just to give you a little background, right? MATLAB it's all it sells all this stuff, right? And they sell you the main package, right? The main MATLAB code, and then you could use everything. But then there's certain things that they'll charge you extra for. So you want to do symbolic? Well, you got to buy the Symbolic Toolbox, and then that's a separate purchase that you have to get. Same thing with statistics. There's a statistics toolbox. There's a Simulink. I've never done anything with it, but if you installed it, there's the hundreds of toolboxes, and all of those are extra costs. We have access to all of them for free, but you go in the real world, you don't have it. But there's a lot, and I'm going to teach a MATLAB Symbolic Toolbox. It's not as clean as there's some programming languages out there that are straight symbolic from the get-go. Like Mathematica is one. CAD is that way. Maple. Let me say Maple. That's another one that is all symbolic from the beginning, and then they're made for symbolic, and you have to talk it into doing numeric stuff. But MATLAB's the opposite. So but the same method stands here. Your calculator, depending if you have a TI-89, it's symbolic, right? It knows how to I take an integral of an equation, it'll give you what the integral is, not you don't have to do numerical integration and stuff like that. So a lot of calculators are this way. Okay, so that's that. So introduction to Symbolic Toolbox. We're going to use it. Symbolic versus numeric computation, right? You can all just keep in mind you can always go back and forth between the two. And you can use the double command or an eval command, and it'll do that. But we'll get into that a little bit later. So let's just go through how you even do it in the first place. So this first part right here talks about symbolic variables and expressions, right? How do you use it? Well, in MATLAB, just create a new file. We'll just do this together. The first thing you have to do is, right, if I just say X right here, right? And then I run this. It'll give... Uh-oh. Let me clear everything. X should give me an error, right? So if I hit X, I had a leftover one, had a legacy value here. But if I hit X, it gives me an error because I haven't defined X. It doesn't know that that is a symbol. It's just like X. X doesn't exist. X has to be a vector or a string or something. Something has to be in that case. But what you can do is you tell it that it's going to be a symbol, right? And so the command for that is just sims. Sims, and then you just label what things you want to be symbols. So I'm going to say X is a symbol and Y is a symbol, right? And so now if I say X, it should just return, oh look, it doesn't give me an error. X is equal to X, right? Everybody try this first and see if you have the symbolic toolbox. It should give you an error if you do sims in the first place. It'll say this doesn't exist. Does yours work?
Yes.
Everybody's working?
It should, because I did download it.
Noah, did you?
That was when you suggested that.
Yeah.
Right.
Yep, those are suggested. Hudson, you get that? Haha. Yeah. The other one I have trouble with is Nathan. I always forget your name too, but Hudson. MTS, you get it? Elliot, you get it? Oh, you did? Okay. Ethan? Not yet? Okay, I'll pause. I'll pause.
You know what I'm trying to do right now?
What?
So I've got a big GPU in my computer.
Yeah.
And I
Graphical,
want-
yep.
And I want to use it for my MATLAB calculations so it won't pass me. So I'm trying to figure out how to configure it.
How to tap into it?
Because you can.
Yeah.
There's a way, but you need like you need a different toolbox.
A toolbox, tell it to go use your graphical user.
So then when
Yeah,
I go
gra-
on random number ones, they'll just like punch through it because I don't have to go through my Z it's awesome.
You can erase my.
Yeah, you can erase
Yeah,
my
I think
computer.
I might be able to beat you.
So keep it. So Tim really wants to test his computer versus my computer, and so this is a funny joke. I'm going to do this with him right afterwards. I'm going to give him the one where I don't initialize the variable at the beginning, and then I'm going to initialize my variable, and I'm just going to crush him. I'm just going to crush him. Yeah, that'll be a good one. I've been meaning to do that. He got one a year ago. I got the M4 chip. He's got the M3 chip. Is what it is. And then I'm a Mac. Yeah. Yep.
He has a Mac too.
He's got a Mac too. Yep. And his just a year old, and mine's brand new. And so I'm gonna give him the uninitialized, and I'm gonna run mine with initialized, and then mine will go way faster than his, and it'll hurt his feelings, because that son of a bitch, what he did to me, you were part of this.
Yeah, I did.
Yeah. Because the last class, my structural dynamics class, he convinced all of the students in that class to give me negative evaluations. Kira, right? And Connor, Bryce. So I'm sitting there. So it's out of 5, and it's like a couple days after Christmas. I was like, oh, let's see how I did. See what I can work on, make myself better. And I look up, it's a 2.6 out of 5. So not all of you fuckers did it. Some of you gave me good evaluation. It was like, oh fuck, like what did I do wrong? I had this like existential crisis of like, I thought I connected. I thought it was a good class. I thought these people learned some stuff. And then I went back. I was like, oh, maybe it was out of 5. So then I went and looked at my dynamics one, and it was like 4.9. I was like, well, fuck. What's out of the same one? I failed you. I was like, I failed Gira. I failed Connor. I failed Bryce. It's like, oh my God, what did I do? Like, what was so bad about it? And then I read the value. Then I read the qualitative, and they're like, haha, just joking. Tim did this, and he got and he got. And I just had my annual evaluation today. And I had to go to Craig and be like, Craig, I just want to let you know that 2.6 isn't real. Look at the quality. Like, yeah.
You actually had to talk to Craig.
I had to talk about Craig today. He's just like, I just want to let you know I did a good job. It's
That
just.
Craig is way better than the MATLAB.
I know. It is way better. But just let me have this though.
Well, this could be your pre.
Pre, yep.
Yeah, you can
Yep.
get a good one.
Well, let's give Tim bad reviews back. But see, here's the deal.
He's not 10
That's right. I'm a full
matter.
tenured professor, and Timothy is not, and that bad evaluation could affect Tim's career. So yeah, fuck him, get him. Yeah, no, then we'll get him. I'll get his ass fired. That'll show him. That's way. Haha, you're fired, bitch.
No one can teach this.
Yeah, then I'd be then
we're screwed.
Then you're screwed and I'm screwed. Then you got me teaching steel design. I don't know what I'm doing. Yeah, then yeah.
My last semester.
Yeah.
Imagine
That's
him teaching you steel design.
dude. I think this is what you do,
Yeah,
right? I
you
mean
don't
that's
want that.
yeah. I've never actually done this, but I heard this is what you do, right? Okay. Okay. So just all right. Come back to this, right? Are we good now, Ethan? You up? Okay. Okay. sims x, y, and z. So now I could say, you know, f is equal to x to the second plus y to the second plus z, right? And then what we should get out is a symbolic version of that. I get a symbolic version of that equation, right? It just shows up as symbolic off to the side there. Kind of like it's stacked a little bit better. Right. Right, it is cool, right? And so you could, and then you could do all sorts of stuff with these symbolic expressions, right? You could simplify the expression. Let's give examples.
This is kind of neat. What the heck?
Oh, look at that! It simplified it. I was like, "What? It's just x, right?" Hey, but it's so you can have it simplify an expression. You can have it expand. Right? So it applies the FOIL method, right? Right? Do you guys remember that? Would you remember FOIL when it says?
First out every last.
Yeah, that's damn right? So it goes through it, does that for you, right? You do the FOIL method with it. You could factor.
I don't know that it's doing the FOIL method, but
No, you're correct.
it's just doing it.
It's doing it, but it might be doing some FOIL stuff. You could do a factors expression. Now, I've had a lot of discussions with my kids lately because that's a big thing in algebra, is factoring expressions. When was the last time you factored?
Algebra?
Right, that's right. It's like God, they're like, I don't know how to do it because there's never a real.
We factor all the time in Calc 2. When you're doing integrals.
Yeah, but stupid, right? Yeah, you have to do it for Calc 2.
You have to do it for calculus.
But you don't if you use your fucking calculator. See, that's the point. It's something it's a dumb thing. I think it's a dumb thing because there's no set rules for it. It's just like, well, I kind of look at it, and sometimes this method works, and sometimes this other method works, and the fact that there's no x's there's no x's in the middle means that they're additive. One's going to be positive, one's going to be negative because that one in the middle needs to go. It's such a pain in the ass. Maybe it's because I don't know how to do it. And then I'm trying to teach my kids how to do it. And I'm like, this is stupid because we don't ever do it. You don't need to factor anymore. What's the purpose of factoring? It's to find like the roots of stuff. Well, using the solver on your calculator just solves it right for you. You don't have to factor it. It's stupid.
It's kind of like antiquated.
It is antiquated, whatever that means. Now, I'm assuming antique, like old and outdated.
Yeah.
I think the way we teach math classes in general are antiquated. The fact that they take away your calculator and say, do this shit is bullshit. You have a calculator. You have a TI-89. They'll do all this shit for you.
I
But
mean,
that's not the
the
point.
cell phone has.
You're right, it can't do it for you, but
scientific-
teaching like calculus and stuff is teaching you like high level logic. Like the math is a representation of logic. It teaches you how to think like a mathematician.
I agree with that.
Blah, blah, blah. Right? It's like, I just said it. Right?
Like it's helped out a lot with MATLAB.
Yeah.
Because it's just
Yeah, it helps you appreciate not have to do the bullshit you had to do in calculus, right?
How to do high level math.
Yeah.
All right.
I agree. There's some benefit, but I say this because in my undergrad I took all my math classes. We used the TI-89, and in fact we used the TI-92, which had a QWERTY keyboard, super nerdy. But a QWERTY keyboard. It's just this big mess. But we were able to solve like big ass problems like this and apply it to stuff instead of like, what's the integral of the natural log of x? Who gives a shit, right? It's in the calculator, right? I mean, you know what I'm saying? Like 1 over x.
Yeah.
1 over x is the natural log of x, is the integral, whatever. It doesn't matter. Oh, do I need to remember that the derivative of cosine is negative sine, or one of them's negative and the rest of them? No, I don't need to do it. My calculator does all that shit for me. Right, MTS? You're on my side. You're on the wrong side.
You know what?
Touche. Hey, Hudson. Don't use my logic against myself. Right? They say, can we use chat on the exam then? Because chat is a tool, right? It's a tool. It's just like calculators. But I will say I'm encouraging your using to help you right now. But again, there is a point. We're in a weird. It is such a. Isn't it a weird time? It's a weird fucking time. Because where you have this tool, but then I don't want you to use it too much because then you're not going to learn along the way. But then is it okay that you didn't learn? I mean, it's the fact that you can still do it.
You should argue
you
this
know?
with your kid's math teacher.
Well, that and then writing. Like, what do I do about writing? Like, I use ChatGPT all the
Yeah, we
time
can
to
tell.
write, right? I use it all the time, and so should we be teaching kids to write? I mean,
Yes.
probably, right?
Absolutely we should.
But then at
Because
some
how do they-
point you have to stop doing that, and then you don't have to stop, but you can stop doing it, and then start using ChatGPT to help you write, right? Because there's nothing. I mean, it's a tool. As long as it's like your thoughts and your first version that went into it. I mean, is that okay? Is it not okay? Like you probably run into it through your professors. Some are probably encouraging, and some of them probably saying don't do it, right? Like. Fuck, man, if you took ChatGPT away from me right now, like, I'd be fucked. I'd have to work so much harder. I'd have to
Who'd
work
you
so much.
talk to?
Who would I talk to? Who would I talk to? Right? I don't know, man. It's a weird time. It's a weird time. Like, what are they teaching in? Like how are they teaching coding over in computer science? Right? Like when this exists, right? Like, what are they doing?
To be fair, though, there is a place where ChatGPT just
Can't do it yet.
Laser systems can't
Yeah.
use ChatGPT.
Laser systems?
So like.
Did you translate Kyle?
What's going on?
Like samples off
Oh yeah, sure.
They can't do that.
Yeah.
Like, there's a lot it can't do.
No, I can't do yet.
They can't grow
Yeah.
biofilms.
They can't go yet. Yet. Well, one thing I was reading the other day, what's really weird about it is
I'll
like
ask.
when we used to talk about like computers taking over, right? It was all the manual labor that we used to think, right? Like, oh, we're gonna have a my vacuuming will be done by a robot, my lawn mowing will be done by a robot, and it does, right? But then all my rock quarry, my mining will be done by some robots and stuff. But what's really fucked up is that's what's hitting us now. It's the intellectual part, right? ChatGPT and AI is doing the intellectual part, and then we're gonna be the fucking laborers, right? Because we can grow biofilms and we can operate a shovel, and then they're doing all the upper level stuff. Like, be nice, always be nice.
But there's
It's like
there
we
is
can make the
point of it
concrete.
that, would you feel comfortable if you got told the building you're standing in was designed
No,
by
not yet.
AI versus
Yeah, well,
having someone designed by an AI but having a human check
yeah.
that work?
I mean, Sean, I'll tell you this. Former students of mine are designing buildings, and oh boy, right? Like I'm pretty worried about that. I'm pretty worried, and in fact, I maybe would trust the AI over some of those
Tim
safety
often
factors
says
right
he's never
there.
stepping in a building I designed.
That's what he said. He often, yeah.
Specifically.
You're fine. You're fine. I'll tell you this. I told you this before that when I graduated from Carroll College, there was a person in that class, in one of my class, geotech class, asked the professor, do you have to deal with soil pressures differently when you're on an island versus if you're on the mainland? And then the instructor's like, what do you mean? And she's like, well, so that it doesn't sink. I swear to God, and she asked that question like right in front of us. All of us like, oh my God. She went on and took the FE and passed the FE, and she's a practicing engineer someplace.
Moved away from Carroll.
It could be Carroll. The other thing there is Carroll College. Maybe that's part of the problem. That she got that far in that program, just like, oh shit. Right? Teaching structures 1 right now too. Right? Right? Like there's a big issues with figuring out what a tributary width is. Right? Like that's a tributary width. It all flows into the thing. You guys are all part of this too at one point, right? When structures 1, and you're learning, and everyone's trying to teach, but I'm just like, what? And then somebody the other day did tributary width, and then took that number and multiplied it by 3 because there was 3 floors. It's like, oh my God, it's an interior beam. How are the walls divided? It's like fuckers, like and then it's like, whoa, I don't know. Anyways,
After I finished this timber homework, I asked Chat to do it, and DeepSeek was pretty close. Chat was like way off.
yeah.
Like terrible.
I will say, and I said all that stuff, but it had some issues with. It had some issues with this this thing we're gonna get into here in a second. Oh, we don't have expression. It had some problems. So you can also do substitutions. You could tell it in F, substitute for X, put Y squared into X. That's what this command does. And so you could substitute that subs command says you put the first thing is where you want to substitute into, and then what do you want to substitute in the x place? I want to put y squared. And so it just took that equation from up above, right? X squared plus y squared, and in the x squared it put y squared. So we end up with y to the 4th down here. So it could do substitutions. And so when we do these more advanced ones, I'll show you that in a second. So it could do, and you could see how this would be powerful, right? I mean, this is just different than what we've been dealing with so far. This is actually just this is a fancy calculator. Okay, it'll also do calculus, right? If you want to take derivatives of stuff, so that's what this command does. It takes the derivative. What's interesting is it's the same command that we used with numeric expressions, right? When we took the numeric expression, it was there was a command called diff, and diff returned the spacing in between elements. But built into the code some places, there's an if statement, right, that says, oh, if you use diff on a symbolic expression, take the derivative. If you use diff on a vector, find the distance in between them. So it's the same command, but somewhere in diff, there's got to be this, which one are you going to do, right? And in this case, I give it a symbolic expression, and it takes it returns the derivative of it, right? And so 2y is a constant, and so that's 0, and then so the only thing that gets returned is 2x. Yes, Gavin?
Can you, after you do all these, can you put a value in for the variables after?
Yeah, you can. We'll do that in an example. And what it ends up being is that subs command.
Oh.
Right?
Okay.
Yeah, the subs command is you could say, hey, in all x's put 1, and all y's put 2, all put this, and that'll substitute in those things, and you can evaluate afterwards. Yeah, absolutely.
Are those like different sublines that you do? Or we're gonna do an
Yep,
example?
we're gonna do an example. Okay.
Oh,
So
I
that,
see it.
yeah, you see it down at the bottom.
I see it number 10.
Okay. Partial differential equations. Right? You can take that same equation and do the partial differential equation of it. You could do integration. You can integrate. Same thing. Int is a command that's different depending on what you're looking at, right? And so then that'll do the integral. It should give us a constant, right? Constant of integration. Oh, it doesn't give it as constant. I thought it would have given us a plus C. It shouldn't be like when you integrate something. Oh, 2?
Yeah,
Huh?
Shouldn't it?
Yeah.
Take the integral of something, that should be a plus a constant. It didn't do that.
Right, but it's probably.
This thing is thinking that you defined 0 as something.
Yeah. Yep, could be. I think you can put in, can you put in bounds?
You put it down, that's kind of cool.
I'm putting a bound. I need to make L a symbol too. Oh, hell yeah, you can.
Do L and L squared or something, or up to 2L.
2L right here. Woohoo! Look at that. Right? It's pretty cool, right? I mean, it's just like you would usually put it in your calculator, right? It's exactly how you put it in your calculator. It's just the one thing is you got to make sure you define and tell it that it's going to be a symbol to begin with, right? Otherwise, it tries to, if I wouldn't have crawled out Sims, if I didn't call out that up above, it should give me an error right down here. It says what's L? Because again, L's got to be something. It's got to be numbers or something like that, unless I call it out as a symbol. And if I put it as an L up there, then it'll work. Okay. It'll take limits of stuff. This is basically all of your calculus class. Oh yeah, there's a bounds right there from 0 to 2. Return the thing. Limit expression. Oh, let's do this 0 to 2. I want to show you something here.
Maybe learning how to factor is just separating out those who like think that
Yeah.
way.
Back to
It's the original readout class.
yeah. The original weed out class.
Which is half people to business and half people to
Yeah. I mean, I would honestly I never want to be like the judge of people, but I mean that's what I'm hired to do, and I would like to literally just sometimes just go just like you said, just like how about this guy? There you go that way, right? Just like it's just what's that?
Your integration of art.
And it's fun. I will say nobody in this room I put in the category of. I will say you've already been separated. I won't say which side you're on, but I'll say I'll just say it's already been carved, but I haven't said which way you should go. Right. I think I will say that probably in this class, instead of like going to business, I probably could put it through you and be like, how about you don't go into anything coding related, and how about you go into something coding? And there's nothing wrong. Just some people think certain ways, and some people think the other ways. Some people like it, some people don't like it, right? I mean, how many people hate it so far?
I know.
You're in the. But do you like it though? Do you like it, Connor? Or you're just like, I think they go hand in
In your
hand.
mind, you're like, no, Connor, don't go into coding.
I know. I didn't say that.
I can tell.
Yeah. But you agree, though,
I
right?
agree, though.
You agree, though, right? It's people think differently, right? And that's fine. It's in this at this stage, it doesn't matter, right? You don't need to know how to code to be a structural engineer. You don't have to, right? And nor do you, What's that? Thank God. And in fact, you probably won't. But again, one of my goals of this class is just let's start thinking about like what's happening in a computer is what you're doing. Like you using, and that is one thing I will 100% guarantee. When you go to be a structural engineer, or poop and pee. But if you go to be an engineer in general, you will use a computer heavily, right? And isn't it a good idea to kind of have an idea of what's happening behind the scenes? And it is, no matter like the operating system in general is a while loop. It's a big ass while loop. It's just going, and it's like do this, cycle around until you get turned off. Right? Until you get to, other than that, it's just running the thing. And inside of there, there's a little thing that's saying, there's like, oh, I'm gonna move my mouse to a certain spot and I'm gonna click. In that operating system is a little thing that says, if your mouse is in this region and the left button is clicked, then open the program. Like that's in there. That's in that operating system. If I'm in this area and I right click, bring up a little window instead and click these other things. Like it's happening. That's just happening behind the scenes. And I at least have to know that exists. I think is important. So this isn't a wasted class for you, Connor. That's right. Also, you've learned that you hate it and you don't want to go into coding, right? That's one goal is just so you understand what's happening computer wise. And then the other reason is maybe you find out you like it. Maybe you find out you love it and you want to get into it and you want to get better and you want to go into a profession where you do it, because there are professions out there that hire structural engineers. Well, but even like there's like those guys that work at IES, right? There's 4 of them that work there right now are all former grad students of mine. That's all they do is they code all the time, and that's what they like. I've had a couple grad students say, I'm not going to do structural engineering. I'm going to go work at Los Alamos Labs and I'm going to code, and that's what they do in Los Alamos Labs. There's 2 of them that do that.
Got his undergrad in mechanical engineering here, and then he got into coding, and he worked for Oracle for a long time, and he's a coder now.
Yeah. Yeah.
He just likes
There's
coding.
structural engineers that are, my cousin works for a company that's building quantum computers and they're
Yeah. You know what I'd like to learn? How quantum computers work. Right?
I don't even know what that means.
I've heard, what's that?
I don't even know what that means.
There's a new, they just came out with like a chip. Google came out with one and then Microsoft came out with one. And they say something about like the number of calculations that it does would take the fastest regular computer like 1 trillion years to do the calculations that a quantum computer did. And they said it's going to change us fundamentally because something that's that powerful, any encryption's gone. Any encryption's gone, right? Like every password you have, every encryption that they have on every nuclear arsenal, whatever it is, it'll just take mere seconds to go through and break into that. And so, but there's some reason. There's like it has to be held at absolute zero. Have you heard this?
You need hundreds of gallons of liquid.
Yeah.
It
It's
takes
got to be close
so
to as
much
close to
energy.
zero as possible because of stuff. But then all I've ever heard somebody explain to me, maybe I gotta talk to Chad a little bit, is all it's ever explained to me was that, right, in a computer, this is, again, just blows my mind. Every calculation you do just boils down to ones and zeros. Everything's ones and zeros. Every multiplication, everything is just an interpretation of ones and zeros. And every number is, do you guys learn about this ever? Like the binary number, like the 0, 0, 1, 0, 1, 1, 0 is actually a number, and then it's all just like triggers on, like I just say this, I should probably learn how a regular computer works first before going on to, but it does that, and then the quantum computer, no, this is the crux, is that a 1 and a 0 can exist at the same time. again, it doesn't make any sense to me. That doesn't help. But it's doing something where they can exist at the same time.
Correct. It's called superposition.
But how that makes it faster and shit, I don't know. I think they're prone to errors, and they're trying to work out to get less errors.
They
and stuff.
have massive amounts of errors when they sort up, but they cycle through themselves so fast.
Do you get it?
Yeah, they cycle through.
Maybe you can explain it to me. Maybe you do a presentation.
Who can come in and give a presentation?
Yeah.
Because I don't understand.
I don't get it. I don't get it either. But it's an area that we're headed, and it's like. But sometimes I wonder if we're really headed that way, or if it's just like pipe dreams, right? Like, you know what I'm saying, Akira? Like they're promising us this.
We're talking pipe dreams that rail network in California is done.
Yeah. Cause does it work? Yeah. See, I mean, it's like, oh, it's gonna change the world, and then it doesn't actually work, right? Like, how many self-driving cars we got right now? Like, not like we were promised that we'd all be in self-driving cars by now, and we're like, we're not, right?
There's no flying cars.
Flying cars, shit like that, like.
There are some
There are, but they don't use them that much. You ever see that where they trick them by putting a cone on the? Because I guess you heard about this? They have like San Francisco. There's a bunch of them going around, and then there's people protesting, and they just put a cone on the hood and then just walk away, and then it's stuck. It can't go anywhere.
That's so funny.
No. Okay. Anyways, I digress. Although related to civil engineering computations, you add AI and a supercomputer. Quantum computer. That's why always be polite. Always say please and thank you.
I don't think that's gonna matter.
We're going back to you dial into a quantum computer.
Yeah.
If it decides that humanity's a problem, I don't think it's gonna.
Yeah. The environment, right? What they say, like the environment is doing it, and we're the problem. So like take us out in the process. Launch nukes at each other.
I feel like that'd also be bad for the environment.
That's touche. Eventually though. Biological. Oh yeah.
Yeah, that's where I come in.
Don't give it any ideas. Don't give it any ideas, right? Yeah, like diseases. Just fucking take us out with diseases. Yeah, I mean, yeah. Anyway, I just okay. Diseases. Okay, so let's come back to this. Bring it back. Let's do some stuff here. Now, like, look at this. I took the integral of x squared from 0 to 2, and then note that, like, it gives me a fraction. That is the exact answer. 8/3 is the exact answer. And like I said before, like, maybe you wanted to plot something. Maybe you wanted that like an actual number, and and it's a symbol. 8/3 is actually a symbol right now. And if I want to bring it back, what you could do is, I think you could write eval. Oh, def. Is that the last thing? If you do eval of it, what it does is it evaluates the expression. It's like, oh, maybe you meant 8/3. And then so then MATLAB goes, all right, what's 8/3? And how it would usually return 8/3, if I come down here, right, 8 divided by 3, it just returns to me the answer of 8/3. And so by eval does that. It says evaluate this function. Okay. One way you can plot it too is you can have your x's. It's a we go. All right. I'm getting ahead of myself. So that's eval. You can I think double works there as well. It converts the symbol to a double. That's the other way to do it. It's like, I'll take 8/3 and turn it into a double as opposed to a fraction. And now it's actually a number that you can treat it as like an actual number at that point. Okay, let's see what else it says.
Like, just 1 second. The 0,2, that's the conditions?
Yep,
From 0 to 2.
lower bound, upper bound. Yep. So you're taking the integral of x squared with respect to x from 0 to 2,
Yep.
right? The lower bound and upper bound.
Wait, so Mike, would it not
Yes, Gavin.
introduce 8/3 then as like a number? Does it have to be like?
Depends on what you're trying to do with it. Like I think if I did that.
But it's still numbers though.
It's a symbol right now though. Just like a string. Let's see. So def. Oops. Right. If I tried to do that times 4, would it be okay with 4? Oh, it does. Yeah, you could do lots of stuff with it, I guess. Right? I thought maybe if you multiply it by a number, it would say I can't do anything with that.
Do you plot something with it? Or do you have to convert it back to
Let's try that.
Well,
Let's try. X is equal.
Right, but like if you're just trying to plot it, you can plot the symbol, then like
It might not do it because it might times.
oh no, so
Yeah. We'll get to F plot. Oh, I did it.
well, like for doing that,
It plotted it. So I don't know. I think you can do some stuff with it, but if it still had a variable in it, like this just went into 8/3, but it's like 8/3 X, then it wouldn't know what to do with it.
Yeah.
Yep. Okay. So then come over here. I made x's equal to something. Yep, I made x's go from 0 to 10, and then took that and multiplied it, and so it knew what to do. So if you look at, I mean, just to show you what this is, this should be a bunch of. Yeah, a bunch of fractions. It'll plot the fractions, I guess. I didn't think it would do it, but it doesn't. The F plot, we'll get to that one in a second there. Elliot. Solving equations. This is really helpful, right? This is the one that you would have used to calculate what T max was. Right? And returns to 2 is a vector because both of those answers are right. Plus or minus 2 is the right answer to this, right? But then when you do these, right, obviously the first thing you got to do is define what your symbols are, right? X has got to be a symbol, right? And then just be really careful. It has to be an equal there. Because otherwise it tries to shove 0 into 4 is what it tries to do, right? If you says equals, if you don't do the equal, then it tries to make it equal, right? We already use equal, right? Like x equals 7, then it takes 7 and shoves it into x, and then x now is 7 after that point. If you just use a single equals, you'll get some sort of error associated. If you equals, it says they're kind of, are they equal to each other? Like, and then do some calcs from that. I think this will give me an error if I don't do one equal. I say, see, and that's what equals. This is what am I trying to do? Trying to shove 0 into 4? I don't know what to do. But equals just say we're going to compare them. Like they're going to be equal to each other. Are they? And then you solve for the x that works. And so again, it gives you 2 answers because there's plus or minus 2 is the answer to that. Just systems of equations. Again, this is exactly how you do it on your TI-89. Did you guys all convert to TI-89s?
84. Plus
So bad. I thought I put on a good. No, Ethan, damn right, it was worth it, wasn't it?
Yeah, 89.
was it
Well, the batteries ran out a couple months ago.
So you haven't missed it.
Is that like if you pass the TI Inspire, or is that?
It's equivalent to. It's a cheaper version of the Inspire. The Inspire's good. Inspire. Do you have the Inspire?
No,
What do you got?
84.
Loser. What we got? God, why didn't you guys listen to me?
I figured,
MTS, what do you got? God.
I figured when I got to a point where the 84 wasn't good enough, I'd get a new one, and it's been fine the whole time.
Ethan, though,
Yeah.
right?
I've literally had my 84 since high school.
And you're solving high school problems. What did you go?
It's
I
great.
ended up switching.
What did you think?
It was good, but it also ran out of batteries.
You
and I've been
sons of
using the
bitches.
84.
Inspire? You got the Inspire?
They're rechargeable.
Oh, the Inspire, not the 89. The 89s aren't. The Inspires are. And you got an 84?
Right here.
You, what do you got,
Great
Elliot?
about it.
The Inspire. It's cool, isn't it?
You can like do.
Oh, there you go. You're good. You're all right. You're right. It does make things different.
Drills and stuff with it. It's pretty robust.
Are you doing that often?
Yeah.
Also, like the probability stuff is slightly better. I was.
Yeah. Yeah. This is not, nobody's running a solar-powered calculator, right? Right? Nobody's off one of those. But you don't use it.
Yeah, but it's.
You do Wolfram Alpha for the complicated stuff? Absolutely. So that it does a system. This is how almost exactly how you put in a TI-89 to solve a system of equations. You put them in square braces. There's your first equation that you're trying to solve. This is the second equation that you're trying to solve, and then you say what you're solving in terms of. And that's exactly how you put it in TI-89, except for use curly braces as opposed to square braces in a TI-89. But so it'll solve that system of equations for X and Y.
See something cool that I did?
Yeah.
I built in water resources. I built all of my Manning's functions into my calculator.
Yeah.
All of my Manning's equations.
Yeah.
And then a bunch of variables, so I could change the stored variables, and I got 100% on that exam.
Damn right.
And because you can build all these variables and functions into the calculator.
Yeah. Huge nerd.
Can't do that in your
Huge
board.
nerd, but I like to see it.
And then I walked into my exam, and I walked out 30 minutes early, and I did better than everyone else.
That's right.
All because of this little box.
TI-89 same thing. Okay, so then the last thing we're gonna talk about is it'll solve differential equations as well, right? So if you have a differential equation, right? Differential equation. I'm gonna define my symbols.
Which was freshman year, maybe 130.
I mean, I start these tangents and then I try to get back on the real one, and then it takes.
I'm paying attention.
Yeah, it was my fault. I'll take the blame. So to do a differential equation, right? And the ODE stands for an ordinary differential equation. So what you do is I set my symbol as y, then I take the derivative of y with respect to x, right? Plus y is equal to 0. That's the differential equation. And then the command for it is just desolve, right? And then you can add in initial conditions with it as well. So let me see if this will. Oh, it copies all this stuff. Oh my god. It gets all the numbers too. That's what it does. I gotta do line by line. Right. Define my sims. I define my ODE. Right, you can call it whatever you want. It's just a variable called ODE. Right? That's my ordinary differential equation. You can look at it too. You can look at the symbolic, right? It just says the derivative of y with respect to x plus y is equal to 0. That's the ordinary differential equation. So if I wanted to solve that differential equation, the command is desolve. So the y solution is desolve ODE. Right? And there's the solution to that ordinary differential equation, right? It's C1 times e to the negative x is what the solution is to that differential equation. Right? And we did these in structural dynamics. We did all sorts of differential equations, right? And then you can add it, right? The C1 that's floating around is a constant that's going to be determined based on the initial condition. So this is how you would do it. You basically do a desolve of the ordinary differential equation, but then you put in the initial condition. So I want it so that y of 0 is equal to 1, right? So you need an initial condition for every prime that you have. And so what it found that constant to be, they found the constant to be 1. So that C1 went away because it solved for what C would need to be for y of 0 to be equal to 1. And so then it ends up C1 has to be 1 for that to happen. Okay. And then to plot your symbolic expression, right, we could do this one. It's an fplot command. And it's really similar to the plot command, except for now you actually give it, let's do it here. Expression is going to be that. And then, my expression is that. I've defined sim. Sim's is already defined. Right, x squared plus 4x is 4. And then if I want to plot it, again, it's the fplot command. It's a function plot. And I want to plot the expression. And then I think you got to say the lower bound and upper bound. Yeah, -2 to 6. Yep, so you give it the lower bound and the upper bound. -2 to 6. Okay. Which is different, right? Like when we plotted stuff in MATLAB originally, right? You had to define x's, and then you had to define all the y's, and you plot x versus y. And then the bounds of it was dependent on what you chose as your x. If you said your x being -2 to 6, your x's would go from -2 to 6, and then your y's would calculate it, and then you'd plot it afterwards. In this one, you just say plot the expression, you give it the lower bound and the upper bound, and it plots it. Right? Part of the problem with symbolic stuff is it does take longer than doing stuff numerically, and sometimes there isn't symbolic solutions to things. One of the reasons for doing that. You can see that this is me and chat we're arguing here on how to do the title. That doesn't make sense. There's some errors and stuff in there. You can plot multiple at the same time. You do expression 1, expression 2, and then put the same bounds, and they'll plot 2 different things on the same plot. Right? I would assume that hold on and plot and stuff like that. I would assume those work as well. Okay, So let's do. We have 15 minutes here. Let's do let's talk about this one. So this is structural engineers. We talked about this briefly before, right? A simply supported beam of length L is subjected to uniform load W, right? This is the fourth order differential equation governing beam bending. This should actually be negative W. It's equal to negative W. The fourth order is equal to negative W. Otherwise, your deflections end up being positive. And you don't want that. We always talk about negative that way. Anyways, here E is the velocity, I is the moment of inertia. And then what we need to find is, so when you're solving differential equations, by the way, just refresher, what you're after is U. I'm after what the displacements are. Here's the differential equation governing beam bending, but what I solve for when I solve a differential equation is U. We don't solve for X, we solve for U as a function of X. So what function of U, if I take the fourth derivative of it and I multiply by EI, gives me W, right? That's what we're after. Right? And so afterwards, when we solve for U, you should be able to take the fourth derivative of it and then multiply by EI, and it should return to you W, right? Is the kind of idea. So we could solve this. We could solve this U, and I want to do this for a simply supported beam where the moments are equal to 0 and the displacements are equal to 0 at the ends. Okay. So take a minute and try to do this. Right? Try to do this. We want to solve. We're going to do it symbolically. We're going to do it symbolically. We're going to solve this fourth order differential equation. So one of the first, so the answer's there, right? But try not to look at the answer. Go against my don't use the tools in front of you. Push yourself a little bit. See if you can do this. So and we can do it together. Should we do it together? First thing you got to do is you got to define your symbols, right? X, U, E, I, L, where's my equation here? I just want to make sure I got. Oh, I shut it. We don't need the constants. Oh, W is the other one. W. My ODE is equal to E times I times, we're going to go diff is the command that takes the derivative, U, comma, 4.
Do you need the X in there too?
Good question. Let's see. Yes. U of X. Clear. We got U of X. There we go. Yep. So it has to be, you have to define U as being U of X, telling it that U is going to be a function of X. Okay. There's my ordinary differential equation. And then we're going to use dsolve. Okay. Dsolve, my ODE equal, negative, should be negative W. That should give me an answer. Okay. So that, again, you're trying to solve for U as a function of X, right? And then this equation, the way it's written right now, is that solution. That is the fourth order differential equation. Or sorry, that's the answer to that fourth order differential equation. And notice all the constants, right? C1, C2, C3, and C4. The reason we have 4 constants is because we have 4 primes, right? So basically, always think about this. We're solving a differential equation. However many primes there are, EIU prime, 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 that means that's however many primes there is how many initial conditions you have to have. You have to have initial conditions because this is the same equation that applies to a simply supported beam, a cantilever, all that stuff is affected by this. So I got to solve for those constants. If you look at this solution that's on there, it does it 2 different ways. It does it where it leaves C1, C2, C3 as separate variables and solves for the variables using solve commands by applying those, or you can apply the boundary conditions. So for a simply supported beam, what are the boundary conditions of a simply supported beam? Kayla. I'm just joking. Simply supported beam. What's that? Deflections are 0 on either end. right? Deflection. So then the way you add those in here, right? You put a comma, and I think you do square braces is what you do to see how many you got. So you want u of 0, right? It equals 0, right? The displacement at x equals 0 is 0, right? The other one is u of L equals 0. Right? I think this will still give us an answer here. Right? We're short. Notice that C2 and C3 went away because I took care of 2 of the initial conditions. The 2 of the initial conditions that I took care of were the displacements on either end. So this solution would give me answers where they're 0 at either end. But I still have C1 and C2 floating around. Right? So then I have to add in 2 more initial conditions for simply supported. What are the two other ones? Well, a simply supported beam. The uniformly distributed. What's the other initial conditions? The what? The rotations are not 0, but what is though?
The moment.
Moments. The moments are 0, right? That's exactly right. Either you define the load being 0 or you define the deflections being 0 or the rotations and stuff. So in this case, it would be that the moments would be equal to 0 at the end. If you had fixed, the rotations would be 0 at the ends, right? And so then I got to come up with a way to do that. And this is where me and Chat's original version didn't work, right? And I was like, what do you mean to do this? And then I had to come up with my own solution. And so what I'm going to do is my own solution is I have to define what my moment is. My moment of x, I'm going to add, you have to add that as a variable, my m of x, we're going to say that's equal to e times I times, we talked about this last time, times diff u of x, comma 2. Right? So e times I times the second derivative, eiu prime prime, that we used this last time, right? We talked about this last time, right? What did we do that for? Oh, because we plotted beams. Yeah. Right. So then the second derivative times ei is the moment. So I'm going to set m of x is equal to that. So then now m of x is a variable. There it is right there. It's eiu prime prime is what that's doing, right? So then down here, now I can add in this initial condition. I could say m of 0 is equals 0, okay? And m of L equals 0. And what Chat was originally giving me wasn't working, and so that works. Okay? And so then that goes through, you give it the initial conditions, and it returns to you the overall equation for this system.
That's pretty neat.
Isn't it? Okay. So then, what's that? Powerful. TI-89 will do this exact same thing. I don't know if a TI-89 could do a 4th order differential equation. I don't think it can.
Deflection for simply.
That's the deflection for a simply supported beam. So let's plot it.
Oh. Right.
Oh, we can.
Full equation.
Yeah. How about this? Yep. U of L over 2.
That is cool.
Well, look at this.
Mhm.
What should this give me? U of L over 2.
It should give you 384 EI. L.
You got some right numbers in there. There's a 5 in there somewhere.
5 over 384.
5 WL to the 4th over 384 EI. This should tell us that.
It should.
Okay. Oh, no, okay. No, right. It didn't save it yet. Nope, doesn't like that either. Okay. I didn't catch it. See, this is my point is I didn't catch it. U2. Huh? Take that, motherfucker! Huh?
That's pretty cool.
I mean, I didn't do anything.
Well, Kyle's broke.
5 WL to the 4th over 384 EI. Huh?
It's not working.
Yes, it is.
Aha!
Mine has,
Huh?
Aha!
Ah!
mine has an invalid index.
Did you put X next to the first YouTube?
Yeah, did you YouTube X?
No.
Yep, there you
Why
go.
would I do that?
Because you have to tell it to,
No,
you have to tell it to the function. Otherwise,
I know.
it tries to index U2, and it's like I don't know what you right? Yeah. Technically, I probably should have. I didn't call out U2 as being a symbol up above, but it must have known because I took it and I set it equal to a symbol, so it must have just known how to do that. All right. So then we can also plot this. Right. Let's use the fplot command. What's wrong? Why can't I plot it just like this?
Because that's in linear. That's in numerical space.
Well, we can't do regular plot because it's not an array. It's not a vector. But I can't plot it right now. This won't plot either if I just say plot U2. Why won't it plot U2? Because
it's symbolic. It's not numerical.
right, and it doesn't know what W is. It doesn't know what L is. It doesn't know what EI is. It doesn't know I. They have to be numbers in order to work. And so you could do that with a sub. That's where the sub command is. So let's put in sub.
Because then we're substituting
Yep.
numbers
For that.
E beta, but all our variables.
Yep, I think I'll do it inside the plot command. Fplot. Nope, I don't want. That's advanced. Let's just do our own. U3 is a function of x is equal to U2 is a function, or subs.
Like sub sandwich.
What was it? What was the command above subs?
Keep going.
Subs. You put the function, what you want to sub in, and then that. Yep, and you can do that as a thing. So I want to go subs U2 function of x. Right in there, I'm gonna shove in x. Nope. I'm gonna shove in W, L, E, I. And you put it in square braces like that, and then you say which one you want. I want to shove in a 1, a 10. Let me put commas there. A 10, a 29,000, and a 1,000. So then it should sub in those values, and so I should just get something as a function of x. Right? Because it just took and it just shoved those things into those places and put it in a new U2 still is what it was, right? We didn't replace U2. We shoved in a new variable called U3. Now I could do the fplot. Fplot U3 of x. And then I put the lower bound 0 to, what did I say L was? L was 10. Damn.
Can you scroll back down? Or up, yeah, wherever it is.
And that should be what the deflection shape looks like. And then you should be able to do I think I went and did some more stuff here that I do. Oh, I did this. I did all in. This is me down here. Oh, yeah, I did this stuff. Just to show you that it's doing what it's supposed to be doing. M. Right, my moment looks like that. My V will be of x will be equal to E times I times diff Q, comma it should be U2, right? Right. So there's what my moment equation is and what my shear equation is, right? And then we can verify what should my m at L over 2 be. We've done it right.
WL squared over 8
Times 2 times 2.
WL squared over 8. So true.
Hell yeah! Look at this shit. WL squared over 8. Moment is the middle of a simply supported beam. What should be the shear at L over 2?
0.
Yeah, I'd go in a building you designed.
Would you?
Yeah.
Wow, that's high praise.
Yeah.
Tim would.
What should V at 0 be? gosh. See, I'm right there with you, man. WO2. Did you do it? Would you go into building and design too?
Sure.
One thing that shocked me, I was in the real world for 1 year, and what shocked me is that I could do a full design and nobody checked my work, which was just like, are you sure? Are you sure you don't want to look at this? It's fine. Like, I don't know if it is. No joke. I did the at Carroll College. We got old MSU stands, and I designed the press box on top of the old MSU stands. And to this day, I'm not sure I would go underneath that, right? Like, I literally remember going to a football game. I remember going to a football game and then sitting off to the sides. Like, I ain't sitting under that fucking thing. It was a windy day. And then also, that was the other thing. They didn't check my work, except for the contractor checked my work and found 2 floating columns that went down to floor 1 and then stopped and then didn't make it to the ground. So, yeah. But they put in some stuff and it was fine, right? But this is.
I wouldn't go to building you design.
Yeah, neither would I. See, when it does it this way, you can't just copy. If you want, you can plot them. What it does in here is it actually plots the deflection, moment, and shear, and then you can see that the shear is like you would expect it, and then the moment is what it's supposed to be doing. It does all that stuff. And that's what the last little code does, is it just plots those things. Cool. I mean, that's a really, like I said, really powerful tool. And so Friday, I'll give you an additional homework assignment. It will be using Symbolic and the graphical user interface. Yep. And then possibly a quick data filtering one. And then that's it for MATLAB. And then Wednesday, 2 weeks from today, is we'll do the final exam, or the MATLAB exam, and then we'll start MathCAD, and then we'll kind of cover the rest of this stuff.
Will you have MathCAD on Tuesday?
Yeah, you'll have MathCAD. Yep.
So it is just.
Go. Yep.